though you won't be seeing a calculation like this on the test or anything like that. I want to bring to your attention box 9.2. There's several things that are interesting about this. The first thing to know is that typically, if you live in an area that has an acidic soil that needs to have lime added to it, typically what you would do is take a soil sample, you would send it off to the lab, they would send you back the requirements for the addition of lime to your soil based on a lot of different information that they would have collected. In this particular case, you've got a soil with a pH of 5.0. And I'm just looking up here, 5.0, you need it to be at around 6.8. The soil texture is a sandy loam, and it's going to mention buffer curves similar to what was in figure 9.16. Now, we didn't go over figure 9.16. I may want to just look back at it. But these are the sorts of curves, and these curves are different for different kinds of soil. And it says, in actual practice, a soil test laboratory using this method to calculate lime requirements should have buffer curves for the major types of soil in its service area. So a good soils lab that's usually found at a land-grant institution, there's some private ones as well, they should have information about soils from your particular area that they can then recommend lime based on those particular soils and the way that they interact with those curves, or what kind of curves they have in terms of its buffering capacity. Some other important things that I want you to do are to look at number 2, for instance. Each molecule of calcium carbonate neutralizes 2 hydrogen ions. So if I put a molecule of calcium carbonate in a solution that has hydrogen ions in it, you will see that this reaction will proceed to the right. You'll have a calcium ion, you'll have a CO2 molecule and a molecule of water. The hydrogen has been taken into the water itself and been remediated or been fixed in the form of water. So that's interesting. Okay, so then we go on to number 3, the mass of 2.5 centimoles of pure calcium carbonate, and you'll see they got that from up here. We estimate that it will require about 2.5 centimoles of charge of lime per kilogram of soil to change the pH from 5 to 6.8. So it says, well, okay, that's neat to know, but how much does that actually weigh? How much does 2.5 centimoles of charge of pure calcium carbonate actually weigh? Okay, we go to the molecular weight of calcium carbonate is 100. We get that from a periodic table of elements, and we find out that 1.25 grams of calcium carbonate per kilogram of soil will meet this requirement that we have to get the soil from pH 5 to pH 6.8. Okay, that's nice, but we don't just have a kilogram of soil. We have, in this instance, 2 hectare field. Okay, so we've got a field we have to deal with, and it's not just a single kilogram of soil. So we take this factor of 2 times 10 to the 6 kilograms per hectare that we may have seen earlier, footnote 4 in chapter 4, if you looked at that. And they do this calculation where they say, all right, we need 2.5 million grams of calcium carbonate per hectare. Well, that translates into 2,500 kilograms per hectare. Well, that translates into 2.5 megagrams per hectare, and that's about 1.1 tons of liming material per acre. Well, that's cool, but this particular type of calcium carbonate that we have access to isn't 100% effective, so it has a 90% effectiveness. Okay, so out of 100 kilograms of limestone, it would be equivalent to 90 kilograms of pure calcium carbonate. So we have to adjust it up a little bit, right? So we were at 2.5 megagrams per hectare of lime that we have to apply to change the pH like we want it to be. Well, it's not 100% pure, so we got to go a little bit more. This is a really interesting number 6. Finally, because not all the calcium carbonate in the limestone will completely react with the soil, the amount calculated from the laboratory buffer curve is usually increased by a factor of 2. So we multiply this times 2 because we know it's not all going to, not 100% of that material is actually going to completely react with the soil. So we basically double the amount of lime that we apply to that situation to hopefully get the change that we need to have happen. This is what goes on behind the scenes when you send your soil sample in, and they send you back a recommendation. And what you would see would be a recommendation like this: 5.6 megagrams of limestone per hectare, probably be in U.S. units if it was a U.S. soil lab. But that's the end of the day recommendation that you get, that you can then call a co-op or whoever deals in lime and applies the lime in your area, agricultural lime, and have them come out and apply that much per unit surface area. Then you would need to go in and work that material into the soil so that it reacts more completely than it would if it just sat on the surface. So this is how we calculate. This is the behind the scenes of how it's calculated. So if you ever do a soil sample and get the results back, you know sort of what goes on behind the scenes.